Today, I want to provide a brief introduction to heterogeneous treatment effect bias. I'm going to talk about why we care about it and what it is. So consider this causal inference model. We try to understand the average treatment effect of an intervention. It can be a drug or a social intervention. And the only way we could do it is through simple difference in outcomes. Note that this SDO contains three terms. One is the true ATE, which we're interested in. The other one is selection bias. And it also contains the HTEB here. At this point, I'm going to assume that you have prior knowledge about what ATE is, what SDO is, as well as what selection bias is. If you don't, just go around and look for some YouTube videos. There are plenty on there. So why do we care about HTEB? Basically, when we try to infer ATE through our estimates of SDO, we don't want two things to mess up the whole estimation. One is selection bias, one is HTEB. So we try to get rid of it. And of course, if we can calculate it, it will be best. So what exactly is HTEB? I'll give you a simple example. Consider we're assigning treatment to monkeys in order to measure the causal effect of attending a lecture on a monkey's test score. Let's assume we assign two types of monkeys to a treatment group and control group. For the treatment group, we only assign less smart monkeys. And we know for sure that there's one thing special about them is that giving them lecture is useless. They're not going to improve on the test scores because of the lecture. And somehow we also have the smarter monkeys. And we also know for sure, let's assume, that a lecture would cause them to score 10 points higher on their exam. And just to illustrate the power of HTEB, I'm going to assign all of the less smart monkeys to treatment. And I'm going to assign all of the smart monkeys to control. And I'm going to assume that all of them would start out with the same test score. Well, apparently maybe the smart monkeys are born with this ability to score 60 on test score. Maybe the less smart monkeys, they had to find tutors, they have to pay more money, they have to spend more time on their learning so that they can have an equal ground starting point as the smart monkeys. But anyways, however they got here, everyone starts out with 60 as their initial score. And we can see that there's no selection bias. Their initial condition or their potential outcome without lecture would be the same, 60, staying the same. So here we have selection bias is 0. And when we assign treatment status, we're going to give all of the less smart monkey a lecture, like 1 hour lecture. So meaning the treatment status is 1. And we're not going to give lectures to the smart monkey. Then we give them placebos. But anyways, and what would the outcome be? For the less smart monkeys receiving treatment, well, to be honest, treatment is just useless for them. Lecture is useless. They're not going to have any improvement in test scores. So their outcomes would be 60, staying still. Now, what about the smart monkeys? We assign them to control group, which means that we're giving them placebo, no lectures. So their test score eventually would be 62. Well, 62. So here, what can we conclude? We can conclude that the SDO, the simple difference in outcomes, is 0. 60 minus 60 is 0. Okay, if we totally ignore HTEB, the ATE would be SDO minus selection bias, which is 0. But this is not true. We know that the average treatment effect is definitely bigger than 0 because for some monkeys, lecture is effective. Lecture can bring smart monkeys 10 more points. So what has gone wrong? It has gone wrong because we ignore the heterogeneous treatment effect bias. How so? Well, let's consider the composition of HTEB. It basically is a percentage of the monkeys, the subjects, the sample size that are untreated, multiplied by the difference in between ATT and ATU. So what is ATT? I assume you know it, but just for simplicity, ATT means average treatment effect for the treated, and ATU is average treatment effect for the untreated. Note that these are all potential outcomes. So in our case, the treated is the less smart monkeys, and the average treatment effect of a lecture, as we have said, on them would be 0. In this case, the untreated would be are the smart monkeys. What would be the average treatment effect of a lecture on the untreated, which are the smart monkeys? It will be 10 points increase. So here, if we have to calculate the HTEB, we basically get 50% times 0 minus 10, which is -5. And as you can see, once we take into consideration this HTEB, immediately we can calculate the unbiased ATE, which is SDO minus selection bias minus HTEB, which is 5. And that captures the true ATE. 10 points for the smart monkeys and 0 for the less smart monkeys, and average out is 5.